Hello, ladies and gentlemen. I am going to talk about the reasons for inefficient SQL performance. So, we'll check the main reason for inefficient SQL performance: stale or missing optimized statistics, missing access structures, suboptimal execution plan, poorly constructed SQL. So reasons for bad SQL is inaccurate optimizer statistics, missing access structures is like indexes, materialized view, partitions, incorrect estimates of attributes, cost cardinality, predicate selectivity, poorly constructed SQL, missing join condition which could result in Cartesian product, using union instead of union all when needed. So you can always use union all if you think there won't be any repetitive information. So union is more like a distinct, and union all is all all uh, all rows. If they are unique, then we don't have to worry about it. Hardware related issues is very uncommon, and if you look at this select statement, is select count asterisk from products P, select prod ID average, unit cost, alias AC from cost group by prod ID, where P dot prod ID equal to C dot prod ID, and product list less than 1.5 into asterisk CC. So if you look at the execution plan, is the transformation taking place, uh, they don't worry about it. If this not taking for place, then you will have to rewrite the code. When you look at this particular example, the result set is not changing, stays the same. So this causes a lot of IOs. This query applies functions to join columns restricting index usage. Make the literal match the column type. When you're filtering, you always have left side equal to right side. So do not put functions on the left hand side. If you put functions on the left hand side, indexes cannot be used. Put functions on the right hand side and that's okay. Left hand side and indexes cannot be used. What if I have to use the function? That is the reason Oracle provides what are called function based indexes. So instead of creating a regular index, create an index with this keyword substring function, like to car employee ID, for example. If whatever you're using in the left hand side of your where clause matches with the index definition, index can be used. So we support what are called function based indexes. If you cannot change this query because it changes your result set, then the way to fix it is to create function based index. So when you're going to do a benchmark with the correlated subquery, and if it says 5.8 seconds and then you are going to convert it to inline view, it will say like 0.6 seconds. It makes a huge difference depending on how many rows are there. Always use quotes, even for numbers. Well, it's a big deal, because in order to make it work, Oracle will do a tune up on the left hand side, and the moment it does the tune up, even though you could be searching on a primary key, index is not getting used and would take forever. When you look in the plan, it says 4 table scan, and you may wonder, I'm searching full table scan, and you may wonder, I'm searching on primary key in Oracle, why is it not using the index? So if it's a to-car field, even for numbers, use quotes, because if you're searching on a primary key, index use is guaranteed. But now, because we have to do an implicit conversion, all you have to do is put quotes around it. Index gets used, common mistakes. You really have to understand the operators in a relational database when you join the current account table to the history table, or when you join a product table to the product history. If you are following the business rule, you cannot have product that's current and history at the same time. Uh, Not possible. So if you're doing a union just to see how many products your company has sold in the future and currently, to do a union, replacing union with union all will make a big difference in performance, eliminating the whole sort phase. Optimizer, because Oracle Optimizer does what are called transformations. It actually rewrites your code. Oracle has these objects called materialized views. And materialized views are tables which have duplicated the data from your original table in a subset on an aggregate format. These materialized views are not the regular views. This will take space in the database, and it's kind of permanent. And the neat thing about it is you can always refresh it whenever you need it. So what Oracle does when somebody runs an application against the base tables, and when you try to do an aggregate, what Oracle does is it rewrites the from clause. That's called query rewrite. It's not called a transformation. This is a very high level of transformation. So when you do a explain plan, it says from materialized view, not from table. Exadata, this is very popular. Easiest way to understand a query rewrite transformation is what Oracle says. If you're producing a result set from 10 million rows, and I can produce this result set from this table, which is a child of this, but it only has 100,000 concept to the storage level. Exadata, so now storage has its own optimizer, and that optimizer says I am aware of each and every block that I have, and you're looking for this data, this column, so you can only read from this block. So it basically gives you the block that you're looking for. Not only blocks, we can even give you a partial block, like 1/10 of a block. It's pretty neat. So what those new products do, they basically cut down SQL tuning to a much greater extent, because storage has its own indexing, storage has its own caching, storage has its own filtering and optimizer. So what you're getting back is like partial blocks from all over the place. So that takes you to the next level. There's storage. There are materialized views. What we are talking is basic transformation, converting a correlated subquery into an inline view. And what is the basic transformation if you go a bit higher? Materialized view, query rewrite, a little bit of extreme level storage. Statistics, AWR and ADDM. So it's automatic workload repository, which is AWR, and automatic database diagnostic monitor, that's ADDM. Business run statistics, and the frequency depend upon the type of business. If you're a bank, one run a day may not be enough, and you may change the frequency to run it 5-6 times a day. So we are doing them automatically, and when we do an automatically, we only do it for the tables where the data has changed 5-10% since the last computation. If inline view is better than correlated subquery, Oracle will do it. Why do we do it? Compute automatic statistics, we do it. Gather system stats, we do it. We don't stop there. If you have a license for automatic workload repository, the AWR and ADDM, you can actually basically turn on monitoring on the entire SGA. And what this does is it looks at the SQL that have a lot of pass time. It looks at SQL that have a lot of weights. It looks at SQL that are doing a lot of physical reads. SQL that does a lot of logical reads, and we call that top SQL. Tuning automation. So what we do is we take a snapshot, every one of them, and we store it in your sysocs table space in what is called a, AWR, automatic workload repository, and you can log in and you can see for every snapshot top sessions, top SQL, and then you can take that top SQL and give it some of our advisors, which are PL SQL packages. One is also SQL Tuning Advisor, one is called SQL Access Advisor. But what do? They basically take the SQL and to try to run it in different possible ways. And if they can find out a way to run it faster, then it will come back and recommend you an index or rebuild an index or make a composite index or create a function-based index or partition your table or create materialized view, rewrite the SQL, compute statistics, anything that has to do with SQL tuning. They can give you suggestions. There is an automation builder also available. Reactive and proactive tuning. It's the English word reactive and proactive. You can easily understand. It's always better to be proactive than reactive. Finding, when you find the problems, finding a solution is very difficult. But if you make sure that it doesn't happen, it's easier. So AWR may come back and tell you, oh, this is a bad SQL, and says run SQL Tuning Advisor, because ADDM doesn't know how to tune it, so it will only give you reports. So automatic database diagnostic model, it can catch up the top stuff, present it all you on an hourly basis, and you can do it 2 hours, 4 hours, or even half an hour. But it's not encouraged to do less than half an hour because of the overhead. We have automation for everything. Sometimes we have turned on tracing, look in the trace file. Sometimes we can just use SQL Plus. If you want GUI, we have a SQL developer. There are $V views, data dictionary that are reports, AWR, ADDM, and the list goes on and on. There are also TKProf, trace sessions, SQL performance analyzer, SQL performance analyzer, SQL reporter, optimizer, SQL statistics, histograms, etc. There are reactive and proactive tunings. Reactive tuning is someone reports me an issue, I look at the problem. Proactive tuning is ADDM. Nobody has called you, but we had already given you a report, what happens in the last one, what is good, what is bad, what you should look at. Statistics, structures, and automation. One other thing that ADDM does, when it picks up top SQL, it gives you what is called a percentage impact report, saying if you fix it, it will have 20% impact or 30% impact. So based on that, you can make a decision and say, I should work on this first and this one I should ignore. So the job is to find out what is top SQL, what is consuming too much of CPU, and all this could be manual. All this could be automated. Rebuilding indexes, if that is good, why don't you go and do it? Computing statistics, if that's good, why don't we go and do it? In Oracle, you can automate all of that. There are a lot of things, flags you can turn on and say, hey Oracle, if you find it, there's more than 3 times, just do it, don't ask me. So you can do manual implementation or you can automate it. So what is important for SQL tuning is statistics, structures, and we can do it manually and we can also do it automatically. Proactive tuning methodology. Simple design is preferred. Data modeling, tables and indexes using views, writing efficient SQL is very important. Cursor sharing using bind variables instead of putting it in quotes. And so that's about it. Thank you so much. Good evening, ladies and gentlemen. I'm going to talk about SQL tuning tasks, steps to follow to improve performance proactively. So, SQL tuning performance maintenance is an important part. So these are events that need to happen in your database on a regular basis, meaning somebody needs to identify the high load SQL, could be DBA or the ADDM. High load SQL meaning SQL with the top weights, too much CPU, too much IOs gathering statistics. So there's a job in Oracle that runs every day to look at the tables that needs regathering of statistics. We talked about system stacked CPU that also needs to be gathered if you have a workload that drastically changes. Rebuilding it into existing index is something that your DBAs will do based on DBA's views, which tells them the ratio of, it's like a fragmentation. When you do a lot of deletes, your index get fragmented, so they need to be rebuilt so that you could save a lot of time. Oracle is not using an index because it needs rebuilding. So the cost is very high. Indexes, so even though you have the right index, right type, it is still not getting used because the cost is too high. So deletes are culprits for that. Maintaining an execution plan is another challenge. If the plan is good, it should be used until it's time to change. There were a lot of methods introduced, hints, storing the plans in the database, Oracle plan outlines, but now we actually have something really nice that says we don't have to use the plan non-stop. Rather, we want Oracle to make new plans, but Oracle should only use new plans if they are better than the old ones, cost-wise, execution-wise, etc. So that's where 11G stands. So there are bitmap indexes, reverse key indexes. So those are the challenges that we have. So even though you have when you look at the basics of tuning OLTP, online transaction processing needs to minimize weight and contention, and data warehousing need to minimize IOs. Means that's bottom line. If you are OLTP, work on contention and weights. If your data warehouse, work on reducing IOs, because if you look at OLTP, the number of logs that you are accessing are not very high. So it is not the IO bottleneck, it's usually a contention bottleneck. So missing index could cause real problems, but other than that, we are fine. Data warehousing, OLAP, we have to think partitioning, materialized views, indexing, specialized storage. So what they are saying here is that if you have too much CPU, Oracle, and too much wait time, too much CPU usage in data warehouse, too much wait time in OLTP, and you keep on adding nodes. Oracle has this product called clustering, real application clusters. Partitioning, materialized views, where you keep on adding nodes for the same database, so you have database being accessed from multiple instances, will not help. Because if you're doing a full table scan, who cares how many nodes you have? And if people are not committing frequently, what difference does it make? This is what I call the baseline. CPU meaning IOs, more CPU. Weight meaning contention, so weight meaning OLTP. Data warehouse, full table scans, big tables, CPU. That's what you're looking at. So if you have these issues, you need to address that. So how do you address full table scans? Well, you partition the table, you create materialized view. You can't tell the end user that you can't do a full table scan. You need to break down that full table scan in a partition scan or whatever they are looking for. OLTP versus OLAP, the data warehousing. Design plays a very critical role. OLTP normalization is very critical for OLTP because otherwise you'll end up with redundant data, and the storage will be a chaos. So constant constraints, primary key, foreign key, normalization. When you go to a data warehouse, exact opposite, de-normalization. What is materialized view? De-normalized data, because the biggest culprit of data warehousing is joins. So if your data is pre-joined, pre-summarized, pre-aggregated, we don't ever do that. That's how you get performance. The design also has to do with contention. If you're doing a regular select and you have for update, select for update, that's going to destroy the concurrency, because when you do a select for update, it locks the rows, and if you're planning on not changing them, then why are you locking them? You should be doing a regular select instead. DBA Decisions based on poor connection management extremes. You log in, you don't do anything, so again, yeah, your process is idling, but it's still consuming CPU. That's bad. Very easily fixable. Your DBAs can set up timeout parameters, and we can log you out automatically. Extreme opposite, too much logging in, too much logging out, logging in, logging out. It's all part of the CPU time. Lot of CPU can go into that. So your DBAs get a breakdown. How much time is being spent in logins, so they can work on that. So extreme of anything is bad. Opening, closing cursors slow down the performance. Bad connection management. You can log in and log out every time you do one insert, and you're going to see how much time it takes. Difference in performance. Log in once and do 500 insert, then you're going to see how much time that takes. So that explains to you how the cursor management works, how critical is the connection management. If you have to do a lot of inserts, you can declare a cursor, open the cursor, keep passing the values to bind variables, and once close the cursors, once all the inserts are done, that will speed up the performance. Access of resources consuming SQL statement. Why would a SQL statement consume a lot of resources? Because it's producing a lot of redo, it's producing a lot of undo, it's producing a lot of temp. So we try to eliminate whatever we can. We can eliminate kills. Use union all instead of union. That was one of the examples of eliminating kills. Creating indexes on those columns. So there's a lot you can do so your SQL consumes less resources. Use of non-standard parameters. Storage management. When you upgrade, there should be some parameters that there are no longer needed. You should need to take them out. Underscore parameters should only be used with caution, with taking to a support. Storage is critical. Stripping, how many controllers you have, how many disks you have, all that is important. And now a lot of things over here are outside your control as an application developer, but if you are a DBA, then that becomes important. So if you are using ASM, automatic storage management, that's good storage. You can run ASM on top of Exadata, that's excellent. Excessive serialization. I explained to you redo, how important redo is if I'm creating index. Do I want to log in? That's a decision I can make, because if I do create index no logging, it takes 1/4 of the time. Excessive serialization, example log table causes excessive serialization. I'll make an update and then take a lunch and not commit. It takes excessive serialization. Select for update. If you're not planning on changing anything, then should not be using a select for update. A regular select would do. Those are 3 good examples for excessive serialization. Inappropriate full table scan, and look at the word, they're not saying full table scan is bad. Inappropriate meaning you're searching on primary key and Oracle is doing a full table scan. That's not appropriate. What went wrong? Maybe your index is missing, maybe your index is invalid. Or remember that case where we didn't put the quote, or we did put the quote. You put quotes around numbers is bad. You don't put quotes around alphanumeric, equally bad. Recursive SQL. What is recursive SQL? There is a lot of SQL that is written by Oracle to get the job done. How do we check table names? How do we check column names? How do we check your permissions? All that is recursive SQL. What can I do to eliminate recursive SQL? Not much. I can cache in more objects in the shared pool, but unless I cut down on the number of objects, that's I'm looking at, there is not much control that I have over recursive SQL. That's going to happen no matter what. Deployment and migration errors. You upgrade from 10G to 11G, but your compatibility is still set at 10G. You're not using any 11G features. You have spent money on getting partitions, but none of your tables is partitioned. That's bad. Exadata. A lot of companies are leaning more towards Exadata now. Well, the whole idea for moving to Exadata is to eliminate indexes, and we still see customers spending time figuring out what indexes they need. It should be the exact opposite. You should be looking at what indexes can be eliminated, because now you've got store indexes. But if you don't have Exadata, that even when you're upgrading, making use of the new features, all this automation got introduced in 10G, 11G, and if you want to optimize your daily work activity, then you should be using these features. So this is what happens in real world. These are the things, and every one of these can be monitored. Every one of these should be monitored. Normalization versus de-normalization. There are design issues, data modeling issues. Like I said, normalization is good for OLTP. De-normalization is good for data warehousing, OLAP, because it eliminates joins. Tables come in different formats. You have a regular table, you have partition table, you have clustered tables, you have table that's organized like an index. It's called IoT, index ordered tables. We need to know creating an index, rebuilding an index, how many columns, in what order, bitmap, B-tree. Views, you create views for security reasons and to hide columns and the complexity of the end user. There is no performance advantage of creating a view unless it's materialized view. Writing efficient SQL is good. Writing efficient SQL meaning try to stay away from negations. That's one. Don't put expressions on the left hand side. That's two. And then you're doing PL SQL, follow some coding practices, because when we talk about cursor sharing, so one person runs a SQL, but he likes uppercase, so the SQL gets cached. Another person logs in, writes the same exact code in lowercase. Both hash values will not match, so Oracle will produce two different plans for the same SQL. This is called duplicate SQL. What is the downside? The downside is we are consuming twice the memory in the shared pool. So if you follow some coding practices, especially with PL SQL, spaces, tabs, uppercase, lowercase, then we can share. That's what is called cursor sharing. Cursor sharing. So what is cursor sharing parameter? What cursor sharing means, if two SQL matches, it produces the same hash value, and in order to produce the same hash value, the case has to match, the space has to match, the number of lines have to match. Is that going to be a huge difference for OLTP? Yes, but in data warehouse, two SQL plans, no big deal. So we also have to uh, gauge that. Use of bind variables has a long history. The way we stand right now, you can use bind variables without taking any hit. But if you're on 10G, if you're data warehouse, you will not use bind variables. Heap versus organized storage. What happens in 10G? If you use bind variables, histograms cannot be used. In order for histograms to be used by the optimizer, you have to use constants. But that has changed in 11G. In 11G, histograms can be used by a bind variables. So that's a true statement as of current release. Using bind variables, good for OLTP. Data warehouse, caution. The regular table is the most popular structure. As the table gets bigger, then you think about partitioning it. Regular table, I don't know if you know that it's an unorganized storage. A regular table is called heap table. Heap meaning if I want to store something, I just throw it. I don't care where it goes. Partitioning is organized storage. Clustering is organized storage. Indexing is organized storage. Storage. Now, anytime you use the word organized, it takes more time. If you and me have to keep our closet organized, then we put the things in it, and it takes more time. Heaping meanings you can put wherever you find space, just put it. So if you look at OLTP, they benefit from heap storage because they want to insert update as fast as possible, insert as fast as possible. But when you have to search through a heap, now it's going to take more time. That's the reason primary keys, unique keys, they help us in searching. Whereas data warehousing says, listen, I have to store once and then I don't change it. And after that, I keep accessing it. So let me spend more time organizing it. So when I'm searching it, it's already stored and grouped. Heap versus organized storage. So when we talk about organized storage, your inserts will slow down. Then we talk about heap storage, your inserts will be faster. But when we talk about locating organized storage will help. And that's the reason most of the organized storage are for data warehousing. Clustering the table, index organized tables, materialized views, none of them is good for OLTP. Partitioning is the only organized table, organized storage that's good for both because it breaks big segments into small segments. So data modeling is very critical. Normalization, de-normalization, materialized views, non-materialized views, lot of indexes, less indexes, bitmap indexes, no bitmap indexes. There's always confusion in decision making. So OLTP versus OLAP, which is data warehousing. If you're running a hybrid application, your main challenge is if you create too many indexes, it only helps reporting. It only helps queries, but your OLTP just dies. Why? Because Oracle creates more undo and redo. It's always against each other, except partitioning. That's the only time it helps both OLTP and OLAP. But other than that, either OLTP says yes or data warehouses. Both will never say yes other than partitioning. So here is your design. Normalization for OLTP, de-normalized for data warehouse, constraints for making sure the data conforms to business standards. Now index and materialized view. Now some constraints are implemented using indexes like primary key and unique key. The way we support them behind the scene is by creating a unique index. But every constraint uses an index like null or not null, check foreign key, that they don't use constraints by default. Materialized views is an example, but if you're running a data warehouse, there are two things are very critical to you: materialized views and parallelism. Materialized view is denormalized data or an aggregate or a subset of data. For example, one person has a sales table and another sales rep is responsible for San Francisco. So what I can do is I can create a materialized view on the base table which only has data for the sales rep. So when she runs a query against my database, select from sales where whatever the condition is, Oracle will rewrite from the from clause and her application is going to go against the materialized view. So rewriting a from clause, not your where clause, not your select, but from clause. You're going somewhere, but we are sending somewhere else because it's going to be faster and you will get the same results. So that's very important for data warehousing. Clustering, what is clustering? Clustering is organized storage. This is a database concept. You have a table which has data for different states of America. Well, by default, the data is stored in a heap format. California, New York, Arizona, Nevada. Where are they stored? Who cares? There is no grouping. But can I store all the rows of Arizona into same blocks physically? The answer is yes. And that's what is called clustering of table. So when you say clustering of tables, that's an organized storage. Clustering tables is hardly used because of the limitations. The restrictions are so high. You need to follow a lot of methodologies. If not, you lose this and that. So no one wants to use it. Partitioning, clustering is good for small tables and lookup tables. Who has small tables these days? So that's the reason those structures are very non-popular. Some of these things are very fancy and they are very attractive, but they have no use, and this one is one of them. Partitioning, on the other hand, is a huge feature. When your data gets big, then your partitioning then you have to partition it. And Oracle will let you partition and sub-partition. You can go to that level and every partition becomes its own segment. It can have its own indexes, it can have its own storage. One can be read-only, one can be read and write. So there are many features available with partitioning. Index. No one to focus on every segment in your database, but needs to focus on the tables that are frequently used, what I call hard segments, and the reports that your DBAs get on an hourly basis. It tells them what the hard segments are, or top segments, or top SQL, top weights, top events. You got to focus on the top 5 or 10. Indexing is very critical. What are the types of indexes? Who will benefit from the index? By default, primary key will have an index. Unique key will have an index. Foreign keys, you got to be careful if you're data warehouse, yes, because they help in joins. If you're OLTP, more indexes meaning more overhead, more redo, more undo. What to index on? There are 2 guidelines for creating indexes. You should index on what's joining, filtering and sorting on, and finally you should index what you're selecting on, which is the last one in the order of precedence. Where clause is more important. What you're searching on, if you're searching on column prod ID, index on it. If you're joining a column, prod ID, index on it. How does selecting and indexing go together? For example, case 1, I have index on column system ID. So Oracle uses that index, finds out the row ID, goes to my table because column 2 and 3 is the table. So all the index gives me is the row ID. Using the row ID, we go to the table, we access column 2 and 3, 2, 3 and 4. Benefits of index. Now imagine another case, my index is on B1, B2 and B3. I'm not searching on B2 and B3, but I added them to the index. And now the benefit is I don't have to go to the table. All the information that I'm looking for is in the index. So why did I create index on C1? B1? because I'm using it in a filter. Why did I put B1 first? Because that's what I'm searching on. That's my leading column. Why did I put B2 and B3? Because my other queries may be searching on B2, my other queries may be searching on B1, B2 and B3, and last but not the least, maybe I'm selecting on B2 and B3. Use of index. So that's how many different ways to look at index. What I sorting, searching, filtering, joining and selecting on. If you created 3-column index, it gets bigger, the index gets bigger, it gets deeper, index gets deeper, the cost goes high. If the cost is high, Oracle may not even use the index, so you got to balance it out. If you got too much on any of them, you're going to destroy it, so you got to balance it out. So should I put a column in the index? Well, it depends what kind of column it is, how big the column, etc. So if the column is small, yeah, put it in. If the column is too long, then maybe you need to think that what you're doing. I'm going to store it twice. Don't you think this is de-normalization? What is de-normalization? Storing the data again, just like Materialized to you. It's a snapshot of the same table. You just stored it again. Column 1, 2 and 3 you stored in table, and the same columns are stored in the index also. You just de-normalized it. You add more columns, you are de-normalizing it more. It would be nice if there are rules in SQL Tuning saying do this and you're going to benefit, but the reality is that the SQL Tuning, nothing is good and nothing is bad. It all depends on situations. And another thing here, going on one step further, if I create an index, what's the benefit? If I don't know, that's where the advisors help. SQL Tuning Advisors. So SQL Tuning Advisor will tell me if you have created this index, your cost will go down and your execution time will go down, and this is how much benefit it will have, and then I may be okay. So that's another benefit of automatic SQL tuning. We can tell you the impact views. Like I said, this is to hide the complexity and columns. There is no performance benefit of views unless it's materialized view. So connectivity, too much connects and disconnects are not good. Staying connected, not doing anything is no good. Making sure surely your shared pool is big enough. Making sure your shared pool is big enough. Sharing cursor means the code that one person writes and runs. When another person runs the same code, I should be able to use his plan. In order for that to work, we need to follow some coding practices. Storage and shared pool, uppercase, lowercase, white space, comments, objects, bind variables. If these don't match, when one person runs a SQL, Oracle stores it in the shared pool, and the plan is also stored in the shared pool. Another person runs the same SQL. How do you think Oracle goes to see if the SQL exists? If you are going to compare one alphabet at a time, then the query will run forever. We don't have time for that. Every SQL run is assigned with a hash number. So when the other person runs the same SQL, Oracle creates a hash number. Oracle will look to make sure the hash number exists. If it exists, we can use the plan. Otherwise, Oracle will make a new plan. So if one person types uppercase and another person lowercase, hash numbers don't match, it's a duplicate SQL. We got two plans in the memory which are exactly the same. Sharing cursors. That's the reason some basic rules need to be followed. Sharing cursors is only important to OLTP because it's going to give you performance in seconds. That's it. If your data warehouse, nobody pays any attention to cursor sharing period, because what are you going to benefit with 1 or 2 seconds? So you have a report that takes 2 hours, and now I'm done with my tuning, and the report will now take 1 hour and 59 minutes and 59 seconds. That's not very beneficial. So this piece is critical only for OLTP. GUI, command line, automatic. Now As far as the tools go, there is GUI tools, there is command line tools, and then there is automatic. All these automatic things, they are either background processes or command line with all of views. They could be PL SQL packages, that's all it is. So that's how we implement them, through a background processes, through a with view, or through a PL SQL package. SQL Plus and SQL Developer. SQL Developer is GUI and SQL Plus is command line. Indexing, data modeling, execution plan, interpretation, with views, are all part of SQL tuning. There are huge overlap between DBAs and developers when it comes to SQL tuning. Is it a DBA's job or is it a developer's job? Because they have to make right decisions on storage and hardware, data modeling. What kind of structure do they want to go with? Should they cluster their table or index their table or partition their table, or just go with the regular table? But the word table, meaning a heap, is the most popular structure. Automatic and identifies bottlenecks. Automations will identify the bottlenecks with Oracle database, which makes recommendations. AWR is the storage repository. Snapshot is a mechanism of producing the data. But after the actual data being produced, ADDM analyzes it. So the snapshot comparison. So once you have a snapshot, then next hour we take another snapshot. ADM will compare these two snapshots to determine if there is an issue or not. So it does deltas. But the snapshots are produced by another process called MMON, and it has a buddy MMNL. These are the producers of the snapshots, but the snapshots are compared by ADDM. So this is the one that will produce a report for you and tell you what's good, what's bad, and what is critical. AWR, so what happens? Let's take this off. So the question is about AWR and how do we think it is. This is how we link it. Let me use a darker color. SGA, SysOx, AWR, and ADDM. SGA is where everything is happening and is monitored by MMON and MMNL. So what they do is they produce the snapshots, and these are stored in SysOx table space. And this is what called one of the component of SysOx is AWR. So if you produce that, then this and this is passed on the PL SQL package called ADDM. This is a PL SQL package. They are background processes, and ADDM will produce a report for you. And this report will tell you what are the findings, top SQL, top weights, what you should do after that. Either it's going to be recommended something, or it's going to say run SQL Tuning Advisor, run this advisor, run that advisor. So if you're talking about automatic identification or bottlenecks, ADDM will not recommend solutions for anything, everything. Normalizations versus de-normalization. Normalization is good for data results in good data model. Who benefits from normalization? OLTP. If it's data warehouse, then the answer is de-normalization. Views should be used carefully because they provide clean programming interface. They can cause suboptimal resources intensive queries when nested too deeply, because security could be a big concern. So you want to hide your columns and complexity of SQL. And view adds a little bit of overhead, kind of, because it's physically like a soft link. So it's like a routine mechanism, but it doesn't add that much overhead. So the best practices are identify the characteristics that must be supported by an application designed for SQL efficiencies. Use concurrent connection, use cursor that are passed once and executed many times. Yeah, this will definitely help. Use bind variables before 11G. It's not beneficial because then I use bind variables for OLTP. Now some of the strategies are for DBA, some of this strategy is for just application developer, and 80% is all of that. And the reason we don't go into partitioning and materialized view is because those are data warehousing concepts. That's all, folks. Thank you.